Hello, today's problem is called search in rotated sorted array. There is an integer array num sorted in ascending order with distinct value. Given the possible rotation of an integer target, return the index of the target. So, yeah, for example, given this array which is 4, 5, 6, 7, and 0, 1, 2, they're actually ascending, but it is rotated to the left. So, the right side, you notice that it's 0, 1, 2, and then the left side is 4, 5, 6, 7. There is actually a pivot here, which is between 7 and 0. Either left or right will be sorted after you found the pivot. Okay, so there's a few ways to solve this. One, the most obvious one is you basically go for a linear time search where you just search for your value. For example, you're searching for 7 and then you just check if each of the node 4, 5, 6, or 7, 8, 9, 8, 1, 2 is the target. So in this case, 7, you found 7 here on the third index, so you just return the third index. But it's actually not the optimal solution. And this problem is actually looking for an algorithm which is a log n solution. If you're going for a log n solution with time complexity, it's always basically searching will be always in binary search form. So binary search is right. You have a left and a right and a pivot, which is the middle. The middle is always like the pivot part. So for this case, okay, how do you solve this? There's a option wherein you can just basically find the pivot part here, which is between 7 and 0. Once you found the pivot, basically search on the left side between 4 to 7 or 0 to 2. But that will result into 3 searches, right? Which is will result in 3 log, and basically search for pivot first, and then you search for left and then the right. Yeah, but can be further optimized is like just do it in a single loop. Yes, you could actually do that. And for example, you're given this array here, or 4, 5, 6, 7, 4, 0, 1, 2, and then you're trying to search for the value 4, right? The pivot is 7. So so how do you do this in a single loop? The trick here is to find where the sorted part is. Yep. So in this case, the sorted part is on the left because 4 is less than 7. You know that this is the sorted part. For the array that is always is rotated, there is always a section where it's a sorted part. In this case, it's on the left, and if the left is not sorted, for sure the right is sorted. So in this case, you'll notice that 6 is greater than 2, so you know that this part is not sorted, but the right side is always sorted. So yeah. So for example, we're searching for value 4, right? We try to search for 4 in the sorted part. Is 4 within 4 and 7? Yes. If that's the case, we go to the left side. Another case is here on the second example here, where the sorted part is actually between on the right side, which is 2, 4, 5. Is 4 within the right side? Yes. So you go to the right side. So that's the first two cases. There is another case where you're trying to search for the value, but it's not within the sorted section. For example, you're trying to search for 0 in this first example here. Is 0 within 4 and 7? No, right? So in that case, you go to the right. Same case here where you're trying to search for 0 in the right side, but I couldn't find 0 here. Then you go to the left side. So that's your 4 cases that you need to take note of. So let's say we're trying to search for 2 on the second example here. So I'm trying to search for 2, and then you found that the sorted part is within on the right, which is 2, 4, 5. Is 2 within the 2, 4, 5? Yes. So we break it down again. So you now have 2, 4, and 5. So the sorted part here is actually 2, 4. Is 2 within the sorted part? Yes. So you go to the left. So you break it down within 2 and 4. And now you'll notice that the pivot is actually the same as the target, because the pivot here will become 2. And that will give you the result. So this is actually how you solve this problem. So let's go to the coding section. So let's start with the left side, which is 0, and the right side, which is nums, len of nums, times 1. So 4 left is less than equal to the right. So basically, we're trying to squeeze in. Better search is always like that. And then you have a middle point where the left is right minus left divided by 2. So if the number m is equal to the target, return the pivot is m. Okay, so you found it. It's because the value is the target of the pivot itself. So now what we're trying to do is try to search the left portion and the right portion, right? So in this case, we want to know where is the sorted section here. So in this case, we check if nums left is less than equal to nums right. So we know that the sorted section is on the left side, else you go on the right side. So if the sorted section is on the left side, we check, right, if your target is within that boundary, greater than equal to target, and target is less than nums mid, exactly mid. If that's the case, we basically squeeze into the left side. So R is equal to mid minus 1, else left, it's on the other side, it's on the right side, so m plus 1. So now let's, what if the sorted part is on the right? If the sorted part is on the right, we check, right? If nums mid greater than target and target is less than equal to nums r. L is equal to m plus 1. We squeeze into the right side, else r is equal to, it's on the left, m minus 1. And then if you cannot find it, then you just return -1 here. So let's try it out. This is gonna work. Okay, test case is passed. Submit. Okay. So yeah, this is how you solve this problem. So what's the time complexity? The time complexity is O of log n. Basically, we're dividing it by 2 until we squeeze them into a single unit, and then the space complexity is O of 1, which is constant because we didn't use any additional space. Yeah. So if you like this video, please hit like and subscribe. And if you have any comments, please drop your comments below, and we'll see you again in the next episode. Thank you for watching.